This is number 15, and the link to the solar heater is below. The heater has a concave mirror and this absorber from evacuated tubes, which convert solar energy into heat for hot water supply and space heating of a house. We understand that the sun rays are focused by the concave mirror on the evacuated tubes. In addition, the tubes receive some energy directly from the sun. This type of solar heaters was tested by me. For example, I made several solar heaters on the basis of this absorber from a cheap polymer film. The results of their testing have been described by my third YouTube channel, and its link is below. Our number 14 can be made from an old satellite dish. It is obvious that here solar radiation can create a high temperature, which can cut an aluminum can and other. We understand that a similar effect can be achieved not only with a concave mirror, but also with a lens. For example, it could be a similar lens which has a diameter of 74 centimeters. Or it could be a Fresnel lens. Or it could be such aqua lens. Typically, such lenses or mirrors are used for cooking. But some people are trying to install a stirring engine to produce electricity. Or it can be an absorber which heats water for hot water supply or other purposes. These solar heaters use old plastic bottles around dark pipes or hoses. Adding some types of darker reflective surfaces can significantly increase the efficiency. Typically, these systems are used for hot water supply. This is number 12, and it is a reality of the solar heaters with number 14. It is obvious that the number 14 requires constant movement in two directions according to the motion of the sun. But the number 12 has a simpler and cheaper design, because these solar heaters must follow the sun in only one direction instead of two. My solar station has a similar design, but it does not require following the sun from morning to evening. The principles of such solar heaters without following the sun were described by these two videos of my YouTube channel. I built the station almost 6 years ago for space heating of the house and for heating pool water. My YouTube channel pays a lot of attention to our number 12 because I see great prospects for this type of solar heaters. I'm trying to reach the cost of our solar heat less than 1 cent per kilowatt hour, and it is several times cheaper than the cost of heat from natural gas. If we achieve this goal, such solar heaters will be interesting for district heating, similar to this solar station which gives heat to one of the Danish towns. If our heat with high temperature will be cheaper than half a cent per kilowatt hour, we can create similar solar stations for the production of maneuverable electricity with a price of 3 or 5 cents per kilowatt hour. That is why my station is testing these cheap mirrors on the basis of reflective polymer films and on the basis of free strips of glass mirrors, which are wastes of various glass workshops. In addition, I am trying to find even cheaper types of mirrors, and for example my previous video described these experiments. Another of my old videos described the features of this mirror, which is a stainless steel sheet. These are my experiments when the sun heats a dark metal sheet and the heat is transferred to these water trickles. Similar solar heaters have been known for a long time, and for example here under the glass, similar heaters produce a lot of heat for space heating of the house. This is another example where the heat of this metal roof is used to heat the water of this pool. A pump directs the water of the pool inside this black polyethylene tube, and here we see the trickles of the water leave the pipe. Then the trickles take away the heat from the metal sheets of the roof, enter the conventional rainwater harvesting system, and return to the pool. The last video of my second YouTube channel describes some results of my experiments. Our number 10 is a heater not of water, but of air, and these solar air heaters can be very simple and cheap. For example, we understand that the sun heats this black wall, and its heat is transferred to the cold ambient air, which here comes under the transparent film. This fan directs the warm air into the building for its space heating. This is another example with the use of this thermal insulation, and one of its sides is coated in black paint, and then the heater is covered with glass sheets. Of course, we know that adding a similar dark mesh can significantly increase the efficiency of our solar heater. Let's look at this solar heater, and here we see a hole through which air comes from a room, and then the air is heated by the sun and returns to the room through this hole. This is a steel sheet which absorbs solar energy, and we understand that the air moves through the space between the sheet and the wall of the house. This is a cheaper version, where the steel sheet is replaced with aluminum foil. In addition, I remind you of these solar heaters which heat stones inside this box during sunny hours. Then the heat of the stones is used for space heating of the house at night and during non-sunny days. Obviously, the dark wall of this absorber will be heated by the sun, and the heat is transferred to water, which touches the entire surface of the absorber. Of course, if we cover it with a glass or other transparent sheet, the efficiency of our solar heater may increase. This is another example of a similar absorber, and it is a sheet of dark cellular polycarbonate. It heats the pool water, which circulates through all the honeycombs of this sheet, and here we see the water inlet. This is a solar mat for heating a pool, and I used it as an absorber of this solar heater, which is described by one of the videos of this YouTube channel. Now I am showing some more absorbers, which were tested by my third YouTube channel, and its link is below. I am interested in these absorbers due to the fact that they are very simple and cheap, and their efficiency is great in comparison with the following numbers of our rating. Our H number is a copy of these well-known flat-plate solar collectors, which are a sandwich of the following four layers: a glass, a dark metal sheet, a pipe system for liquid heat carrier, and a layer of thermal insulation. Solar radiation heats the dark sheet, and the thermal conductivity of the sheet leads the heat to the pipes. An important condition for the good efficiency is the wide contact between the pipes and the sheet, and factories usually make this contact by laser or ultrasonic welding. Unfortunately, homemade collectors do not have the capabilities of that welding, and for example, this master makes that contact between the sheet and the pipes by soldering. This is another example of a homemade solar collector, and we see that the steel sheet and pipes are connected by electric welding. This is another method of joining a metal sheet and pipes without welding. This is also an interesting solution when our steel sheet is replaced by cheap aluminum foil, but the foil should be thick, several tenths or hundreds of microns. This is my version, where I use a steel sheet and screws. I made several such solar heaters and connected them to this hot water system, which was described by these three videos. These solar heaters are similar to flat-plate solar collectors, but these heaters do not have that contact between their pipes and their black sheet, or their contact is so narrow that it almost does not help transfer solar heat from the sheet to the pipes. Nevertheless, these collectors can heat water which circulates through their pipes. It is interesting that their pipes can receive heat from the sheet due to infrared radiation and through air which is heated by the sheet. Therefore, their dark sheet does not have to be only metallic. The basis of their efficiency is absorption of the solar radiation, which falls on the black walls of their pipes. Therefore, the pipes must necessarily be placed between the sheet and the glass. Of course, the efficiency of this type of solar heaters is worse than the copies of flat-plate solar collectors, but these solar heaters are cheaper and they are easier to manufacture. The absorber of such solar heaters is garbage. For example, this absorber is heat exchanger of an old domestic refrigerator. Similar radiators for domestic heating can also be a good absorber, and they are used inside this solar heater. Of course, we can find many other absorbers in the landfill, and for example, this old heat exchanger is working inside this solar heater. The basis of this type of solar heaters is an old water tank which is installed inside a box with black or reflective walls. It is obvious that the sun will heat the water inside the black tank during sunny hours, and the water keeps its temperature until morning due to the thick thermal insulation of the box. Typically, the water inlet of the tank is connected to the cold water pipe of a house, while the tank outlet connects to the inlet of a traditional electric hot water heater. Thus, the electric heater receives not cold water but warm water with a temperature between 30 and 60 degrees Celsius, and this fact reduces its electricity consumption several times. These are some of my alternatives to those black tanks when I replace them with cheap polymer films. This pipe is needed to take heat into clean water for hot water supply, and the inlet of this pipe connects to the same cold water source. I remind you that I tested these simple and cheap systems as the hot water supply of my summer cottage, and they are described by these 3 videos. These are solar heaters of air, which moves through large and cheap pipes. Very often, solar heaters of this type use such pipes of aluminum foil. It is obvious that the pipe walls, the bottom of the heater, and its inner walls must be coated with black paint. Every person knows that water inside a pipe or garden hose can heat up to a high temperature in summer, and usually these very simple heaters are used to heat pool water. For example, this yellow hose heats water well, but here it will work even better, because the hot metal roof gives additional heat to the hose. However, we know that the sun heats not only the roof, but also the ground. Therefore, I did some similar experiments to learn how to take solar energy from the ground, and we see that the ground can heat water to a temperature of 54 degrees Celsius. But the heating temperature will be higher if we add this cheap reflective film, and this old video described my experiments. Pipes or hoses of these solar water heaters form spirals, which are placed on a black sheet. Some heaters are covered with glass or other transparent surface, and such versions may be appropriate for cases of hot water supply. I once made these for solar heaters to explore their capabilities, and I described the results of my experiments in this old video. Before describing the leader of our rating, I want to tell you how my rating was compiled. I purposefully watched several hundred most popular YouTube videos and summarized the number of views of different types of solar heaters. 15 types with the largest amount of views formed this rating. So, this is the leader of our rating, and its total viewers is more than 15 million, and it is almost 2 times more than the number 2 heaters. These are solar heaters of air, which moves through pipes, and we see that the pipes are made of aluminum cans.